Okay, I'm now working on problem number 4, which is conceptual problem 16. Suppose that a car is traveling to the west, begins to slow down as it approaches a traffic light. Which statement concerning its acceleration must be correct? Well, let's draw this. Here's my car. Yeah, I know it's a little VW, so don't laugh at my drawing. It's moving this way, starting off with some velocity, but the velocity is decreasing. Remember how we do the diagram? So if this represents one velocity, and then it gets smaller, 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 smaller as it approaches the traffic light. These were the position dots. Each one of these little vectors here for velocity is getting smaller and smaller. Okay, so the car is slowing down. So what is true about acceleration? Well, acceleration must obviously not be in this direction. If acceleration was in this direction, we would see the velocity vectors getting bigger, right? So that cannot be the case. So obviously my acceleration must be in the opposite direction, resisting the velocity, thereby making these velocity vectors smaller. So if the acceleration is pointed in this direction, that means it's positive. So that would make the correct answer be A. Alright, let's go on to the next problem on the test, problem number 5, which is conceptual problem 21 on another page. Okay. When a ball is thrown straight up with no air resistance, the acceleration at its highest point is what? Alright, again, let's sketch that. So I have a ball, I throw it straight up. It's going to go up, and then of course it's going to turn around and it's going to come back down again. I know it's thrown up with some velocity, which we're not given, but when we say it's thrown up with some velocity, I know up here the velocity is equal to 0. This is a free fall problem, so obviously the acceleration is the acceleration due to gravity. The number doesn't matter here, but the acceleration I know is always down for a free fall problem. So let's talk the answers. Acceleration at its highest point is upward. No, acceleration due to gravity is always down. So that answer cannot be correct. Acceleration is downward. Yes, that's always true. Let's see if there's others. Acceleration is 0. Not unless you're in a zero gravity environment. You always have acceleration due to gravity. Does it the acceleration reverse from upward to downward or reverse downward to upward? No to both of these. Acceleration due to gravity is always the same and it's always down. So the correct answer here is answer B. Moving on to problem 6, which is labeled as conceptual problem 31. Let me get that sheet. Okay. Ball A is dropped from the top of a building. 1 second later, ball B is dropped from the same building. Neglect air resistance. As time progresses, the difference in their speeds, and then we're given a few choices. So following the same problem solving method, I'm going to go ahead and draw it, sketch it out because it helps me to visualize what's going on. So first thing I do is I drop ball A and it falls. Let's draw A actually already having fallen a certain distance. Okay, so this is ball A. Now 1 second later I drop ball B. So obviously ball B is going to be behind A, but it's going to fall also. But what do I want to know? I want to know the difference in their speed. Now remember, speed, not velocity. Speed is the magnitude of velocity. So I'm just looking at the magnitude, not really caring about the direction here. So both of these are free fall problems. Let's just draw what this looks like in terms of a diagram here. Velocity versus time. So let's draw ball A. Ball A, we're dropping it. It doesn't say we're throwing it with an initial velocity. So it's going to start with And by the way, I'm drawing these, I should really draw it this way because the velocities go negative. Alright, so it starts with a 0 velocity, and because I'm dropping it and because positive velocity is pointed up so negative is down, then I'm going to have a curve like this. This is A. Now 1 second later I drop ball B, but it's going to follow the same path. The only difference is I dropped it at a different time, but they both have the same acceleration due to gravity because they're both on the same planet. So what's going to be the difference? Let's come back up here. The difference in their speeds, will the difference increase? Remember, speed is the magnitude here. Well, it looks to me like the difference between them is always going to remain constant. So the correct answer to this problem is B.